So in this box are all the parts we need to build this project. I already did show this face plate, which goes on top of the project. So let's take a look inside and see what we have. This will be my test cartridge, International Soccer, because this thing actually has a cartridge port. We will need some kind of controller, so I got 2 of them. And I'm planning on going the gamepad route and not the switch joystick route. So this will hopefully fit in here. It's a bit tall, you can already see that. So good, there's a second one. Then we have the screen, which is a composite screen, which takes, I guess, 5 volt as an input. And Matthias told me to get this screen because it would be the easiest to fit in the machine. There are some parts which haven't been installed yet. I already came up with the spacers and screws I need to put it together. Here are some sockets for the C64 II PLA, which I have still to unsolder from a C64 II. Then there are a few more parts, some measurements I took to mount the display. We will get to this in a minute. We have a voltage converter, which I might not even need. We have a few push buttons, which are the longer type, which we need for the keyboard. This is an additional board which comes with the other boards, which you can plug on the PCB to use 2 normal 9-pin joysticks or Atari joysticks with the machine. This is a back plate, and this right here is the actual machine. So now on to the fun part of salvaging these chips. I made a list. We need the PLA, which is this one. We do need the 6510, which we don't have here. Instead we have the 8500, which is kind of a next generation 6510, but it's pretty much the same chip. Then we need the two CIA chips, which are the 6526. We have one here and we have one here in the 6526A variant. Then we need the VIC-2 chip, specifically the one on this board and not on the others. This is a 8565 R2, which is here, which is socketed, which is nice. And we need the SID chip, which is the 9-volt variant from the short boards, which is the 8580, which is right over here. So I got myself some padding to put the chips in, go on and pull the first chips out of here. So let's do this now. Okay, so the iPad broke down, with which I'm filming right now, and we got two chips. Don't quite know how far the iPad came along, and I did mark the various spots with the red on the board. So we need this one, this one, this one, and this one. So desoldering gun is right here. Let's get to it. And I guess we will start with a CIA chip on the side here. So I have to do this properly because I will have to put these chips into sockets, and if legs bend or break or whatever, that can be pretty interesting. So I will take my time here and do this right. And right in this case means to set the gun down on the soldering pad and leave it for a second or two to really get the solder flowing, and then you push the button. That up there needs a little bit more soldering, so sometimes it's necessary to resolder a point to get it loose. And I will do that on some of the spots. Put some more solder down there. It's only that spot and down here where the leg is bent. And we will go in again. No, still no luck. So this is one of those things that gets on your nerve, because it works perfectly well up to a point. Okay, let's try adding some solder to this and then desolder again. Yeah, that worked. So, yeah, that is not moving at all. I hate those salvaging jobs. because they rarely go as planned. Oh, okay, we have that. And now there's only this bent leg keeping this chip in place. And I did bend the legs a little, as you can see. It doesn't look too good. Let's hope I can get this out of there alive. Yeah, got it. Okay, that does not look pretty, but at least I got it out. So, got all the chips out that I needed, and I will socket all the other free places here and have a board to test stuff. Okay, so next I tried to test this little display here, which I ordered from AliExpress, and I'm using my Atari 800 XL for the video output. And it comes to life, but as you can see, there's this distortion down here, and that is due to a defective display. So yeah, I got a defective display. That's unfortunate. I guess I will have to order another one. Okay, so I went through the whole over the whole board, checking for shorts or weak solder spots, and did indeed have a few shorts on the board. So these are fixed now, and which is a clear sign that my eyesight is getting worse and worse. I already have some special glasses to see closer. Yeah. So next up, we will go and check for some voltages on the board. That means I have pulled all the ICs, which are all here. And the board is naked, so to say. So there's no IC on here except for the few, I guess 2 or 3 that are really soldered on the board. And what I'm gonna do is I will take the power supply, plug it in, and plug it into the board, like that. So now there should be power on the board. Let me quickly check. Oh, it's already on, so we should see some voltages here. And I did prepare a few spots to measure. The first one being the LS 74 LS14, which is where is it? It's down here on the board. So there should be 5 volts on pin 14 and ground on pin 7, which is down there. So if we measure that, we should see 5 volts. We have the 2114, which is, if I recall correctly, the RAM, which is down here. Again, same spots to measure. And we have the 6510, the processor or CPU, which is up here. And we have pin 6 and pin 21. So that will be the pins we're going to measure. And we will put this on 20 volts, so we can see what happens. So there should be 5 volts or positive on pin 6. 1, 2, 3, 4, 5, 6, which is here, and ground down here. And we get nada, which is not great. Okay, let's measure somewhere else. Let's check the LS, the 74 LS14, which should be ground, no, should be positive 5 volts here and ground here. And we have minus nothing, which is not much. Okay. So maybe let's switch the power switch, which was in the on position, but wouldn't be the first time. And since I used a different switch, maybe this is, so this would be the sane thing to do to check if we have some kind of power right now. So let's check the 6510 again. So I switched the power to off. It was on before. Maybe the switch just works differently because this is not the switch which was recommended. So let me check again. So on the CPU we have pin 6. 1, 2, 3, 4, 5, 6, and we have ground down here. Oh, look at that. So it is indeed the switch, which is now the other way around. Yeah, sure, you could have, yeah, you can put the switch in both directions because it was a straight switch and not an angle switch. I had to angle this myself. So maybe it was meant to be the other way around, but that is not a big problem. So, okay, so now I know that at least the CPU gets 5 volts, which is great. Let's check the LS, the 74 LS14 again, which is in this direction. So 5 volts should be up here and ground should be down here. Yeah, 5 volts. Awesome. Okay. And finally, let's check the memory. The RAM 2114, which is like this, and we should have 5 volts up here and ground down here, and it's 5. Awesome. I guess we will populate the board first, and then we will go and burn the Eprom, and then we can finally test this whole assembly. Just noticed that some of the chips have a bit solder on their legs, and these are round pin sockets, so these have to be really clean to fit in. So I guess I will first put in the CPU, which is quite clean. I hope it's clean enough. But again, the legs have to be super straight in order to not get smashed here. All legs are in and nice fits. By the way, this is an 8500 CPU from the C64 II or C variant. Since we are having the PLA and the 8565 R2 VIC2 chip from the Commodore 64C, I thought it would be fitting to also use the CPU. So next up we have indeed the VIC chip, and we will put that in here, and again we have to check the notch and the legs. So what we have missing is the SID chip, and I will not put this in for now because we have only 5 volts on the board. We cannot use this chip. This needs 9 volts, so I will have to come up with a solution for that. There's a space on the board to put some voltage up converter from 5 to 9 volts. And I do have these converters. You saw these in some retro packages video, but they won't fit in the spot right here. So for now I'm going without the SID chip, and it's not necessary to start the system, so that's good for now. So next up I have to come up with a solution for all the solder on the legs here, and I guess I will fire up the soldering iron and clean those legs. So let's see if we can put these in. Start with this one. Yes, that's in. Very nice. Not sure if I can ever get it out again, but I'm good with it being in for now. So let's see. This is way harder to push in, but oh no, shit, 2 legs are out. That's what I'm most afraid of, to kill the legs here, and now the chip won't come out again. Whew. I was pretty sure that all the legs were in, but obviously not. So there are the bent pins. Let's see if we can fix this. Okay, so let's try again, I guess. Everything is in except for the Eprom. And this is where the BIOS is hosted. The kernel ROM and the character ROM and the basic ROM. So I will have to burn this now. To burn the Eprom, we will be using this device, which is an Epromer or Eprom burner. This is the TL8662 Plus. That is relatively inexpensive if you order it from AliExpress, or costs about 60-65 euros if you order it from Amazon or eBay. And you put in the Eprom, connect this to the USB port of your Windows PC, start the software, select the chip, and go for it. So let's do this now. Take a quick Eprom primer, or Eeprom primer. So there are actually 2 types of Eproms. The standard Eprom, which stands for Erasable Programmable Read-Only Memory, which are these with a little window. You can delete these with a UV light or an Eprom eraser, not any UV light, but a specific wavelength UV light. And we have the Eprom. And you see it's the same as Eprom, but there's an E in front, and this stands for electrical. And that means it's an electrical erasable programmable read-only memory, and that is this one. And we're using this one right here. And you don't need UV light. And so these are usual OTP, one-time programmable. You can erase these, but you need specific X-rays to delete this kind of Eprom. So in practice, these are one-time programmable. So we have an OTP, so we better make good use of this and do it right the first time. Now there's the next thing. these Eproms, the last 2 digits, and this is a 2764, and this is a 28 C256, and these 2 digits are the size of the Eprom, but not in kilobytes, but in kilobits. So this is the 64 kilobits, and this is a 256 kilobits, and you have to divide these by 8 to get the kilobytes, and that is 8, and that is 32 kilobytes. Right. So the thing is, if you program one of these Eproms, you always have to program the whole range. So you have to put something of 8 kilobyte onto this Eprom if you program it, and the same here. You have to put something with 32 kilobytes on this to program this. And if you take a look at the file size of the kernel, the basic, and the character ROMs, you will see that both kernel and basic are 8 kilobytes, and that the character ROM is only 4 kilobytes. So you could easily burn a kernel ROM or a basic ROM on one of these, and this is actually what these are for, or I bought this for. You need an adapter to use this inside a C64 because these have 4 legs more than expected. You need an adapter for this to work inside a C64. But we need these 3 burned into this. And as you can see, this is not 32, this is only 20. So what to do? And Matthias actually said the following: you have to put these 3 on the Eprom in this order: basic, kernel, character ROM, and this has to start at 000 to 2000, which is 8K. This has to start at 2000 to 3FFF, always hex, which is also 8K. So we have 16K filled, but this character ROM has to start at 7000. So as you can see, there's a gap in here, and this is only 4K. So what we do is the following. If this is our Eprom and we have 32K and we do 8Ks, we have our basic here, we have our kernel here, and then we have the 4K character ROM. And the problem is we have only 16K used, and 16K are free, and we have only a 4K ROM. So what we do is we actually put it in 4 times. And that way, the last of the character ROMs starts at 7000, which is exactly what Matthias told us to do, and where the machine is looking for the character ROM. The first thing to do is to download the kernel files, and you can find the links in the description below. We move over to thimmers.net and download the basic ROM, which is this here, basic 901.226-01 bin. We download the character ROM, which is the characters 901.225-01 bin. and we download the kernel ROM, which is the kernel 901.227-03 bin. As I said, links in the description below. Then we need an hex editor. I went and searched for one, and here's a free one. It's called HXD, and you can download it, and you go to the download page of this version, and then you select English or whatever language suits you, and download and install. And then, so you're greeted with this. If you open the program, what you want to do is you want to open, I have my ROMs here. You want to open the ROMs, and if we take a look at what Matthias told us to do, we want the basic to start at 0000, which is pretty much 0. So we open this. As you can see, basic starts at 0000 hex. And we scroll all the way down. And then we take the second one, which is the kernel ROM, and we pull it over here, open a second tab, press Ctrl A and Ctrl C to copy. And we just press Ctrl V to insert. And as you can see, the second file is then added to the first. So the second, the kernel ROM, starts at 2000. And if we take a look at Matthias' document, 2000 is just what we want, 23FFF. And if we scroll down, we can see this ends at 3FFF, which is over here. All we are missing now is the character ROM, and that should start at 7000, but we are only at 4000 now. So what we do is we open the character ROM, pull it over here, same, Ctrl A, Ctrl C for copy, and we go to the end of the file. And now we do 1, yes, 2, yes, 3, yes, and 4. We do 4 inserts or pastes, and as you can see, the last one starts at 7000. I wasn't sure how to do this first, and I asked Matthias how he would do it, and he said use an hex editor, and he also sent me his file, which is the file to burn, ready to go. But I think this is a channel where I want to show how to do things and not to use stuff. So this is how to do this. And now we can compare these files. I have his basic kernel and character ROM assembly right here. And if you go to Analysis and Compare, no, let me first open this. So this is a Matthias file. I will close the 2 files that we don't need. This is our created file right now. This is a Matthias file, and what we do now is compare, and he offers the 2 files. We click OK, and he says the chosen files are identical. So this is how it works, and this proves we have created just the file Matthias wanted us to create and load onto the Eprom. So now let's go and burn the Eprom, and for that we will save the file. And we will put this on the desktop and call this C64 handheld bin. Close this. And we don't need these ROMs. These are now all combined in this one. Okay, so I did connect the Epromer, and now we open the Epromer software, which is this down here. And now we have to select the right Eprom. This is an AT28C 256. And there we go. Take the Eprom, put it in the programmer. Make sure that it's in there. We load the file. and we say okay. Here we are. All nice and clean. Let's quickly check. Yep, it's all there. And then we go on program. And fingers crossed, this works. Awesome. Okay, I guess that's it. We have our ROMs, or our kernel bins, and basic and characters all burned to the Eprom. And that was the part I feared the most, because I only have one of these Eproms, or Eproms, and would have taken a while to get another one. Great, so let's pop it in the machine. So here's our burnt Eprom, and this is the last part that is missing. So let's put it in. Let me just bend the legs a little. Yes. Awesome. I think we are good for a test. So now we need to figure out how to get some... Oh, I just noticed that some cables came loose here. That's not cool. So I will have to resolder these, or the cartridge port won't work. But that's okay. As I said, the SID socket will be empty for now. We have to put this connector over here onto this connector over here, so this will be sandwiched together. But first we need to figure out where to go in terms of display, because the display is not here yet, so I will have to come up with a backup plan. So let me solder these two wires, and let me solder some wires over here to create a small video cable, and then we can try this. Oh man, I'm very excited to check this out. Okay, I very quickly came up with a video cable, which is just cinch, and we will connect that to this video and ground signals, the red one being the video and the white one being the ground, like this. And then we have to connect this pin header over here and this pin header down here. That could be a little tricky without pulling all the wires out again, but these are a ways apart. As you can see, that is not going to be a nice sandwich. That is not going to work, because these headers, these pin headers I made here, won't work like this. They are way too long. So for now, I guess I will just leave it like that, plug it in, and see what it does. This connector should only be responsible for the keyboard, so the keyboard won't work, but all the other stuff should, I hope. Didn't check that, so let me quickly plug in the video cable and we will see what we get. Okay, fingers crossed that nothing will explode. Oh man, here goes nothing. And we get nothing. That's not much. Okay, I'm kind of thinking that the video is not connected correctly. I guess we are in for some troubleshooting. So could it be that these connectors do indeed have to be connected? Then I would just quickly build a connection between them and see what happens then. I did in the meantime send photos of the board, of this main board, to Matthias, who designed the board, and he approved. So there's nothing wrong with the components on the board. All should be good. And he suggested that we do some sanity checks, which you would usually do with a C64, which is to check the voltages, which I already did. And the second is to check for the clock signals. So we have to check the CPU, which is the 8500. We have to check the VIC2, which is on the back side of the board right here. And we have to check the the timer, which is the 7801. And he sent pictures where to measure the frequencies. And up until now, I only had this abomination of, you wouldn't even like to call it an oscilloscope, because it was some kit which you could build yourself. And let me quickly plug this in. And the DC in jack broke on day one. And as you may see, there's not much going on here. And it doesn't measure correctly, so it's always more guesswork than anything. And so I decided to get a proper, at least for my kind of novice level, proper oscilloscope. So there it is. And what we do is we measure the points which Matthias suggested and which you would usually measure on any C64 that's not working correctly. And well, let's do this, I guess. Okay, so the machine is plugged in. This machine is plugged in. The scope is on. And the first thing we measure is the 8701, and we measure on pin 6. Let me quickly grab that. And I have attached this little clamp here. Makes measuring much easier. And we need some ground. Oh, came off again. And I will take the ground from this pin over here. It doesn't matter which ground, at least as long as you have a ground. Okay, so let's switch it on and see what it does. And we get some reading. And as you can see, we get about 8 megahertz, which is the correct clock on pin 6 of the 8701. So the clock chip is okay. And I know that because first there was a dead clock chip in there. So I didn't have a second C64C to test the chips in, and now I have. So I did again pull out all the chips, tested the VIC2 and the clock chip, the 8701, and saw that this chip is indeed dead. So new chip, works fine, 8 megahertz as advertised, plus minus a few hertz. That's good. So next up we have to measure pin 17 on the VIC2, and that should give us a clock signal which is used on the other parts of the board, like the CPU. And yeah, let's check this quickly. So ground is still on. Let's turn it on. And here we get about 1 megahertz, which is totally correct, which is the frequency the CPU runs at and the whole board does. So this is perfectly normal. So this is good. And now we check the CPU, which should on pin 39, which is right here, also should have 1 megahertz. So let's check. And that's pretty much 1 megahertz right there. Okay, so we have the correct voltages on the board. We have the correct clock speeds on the board. That all looks really good. Now let's check if there's activity on the Eprom we did. So if the kernel is really active or not. And if we don't see any activity, and it's just a flat line or a waveform, that means something's wrong. If you get some like static floating data, that should be a sign that the CPU is actually executing. And yeah, let's check that. And on the Eprom, we go to pin 22, and pin 22 would be 2, 4, 6, 7 from the top. 1, 2, 3, 4, 5, 6, 7 from the top, which is right here. And let's switch it on and see what happens. As you can see, there's quite some action in there, so this seems to be okay. Matthias said that if all the measurements are correct, then it's pretty much down to the video circuitry. And what I have to do now is to add one of these PS2 ports, which take Luma and Chroma from the board instead of the composite video, and check if this works. And yeah, let me quickly solder this in, and then we check if it works. The S-Video connector is in. Let's see if we get an S-Video picture on the screen. Okay, everything is wired up. Let's start it. We get a picture. Look at that. That is kind of a picture. Wow. Okay. It looks like the kernel ROM is not executing right. And I guess I have to switch some of the jumpers over here because they are still set to composite video. So let me quickly try to check this. Okay, so I swapped around some logic chips. Again, the dumbest idiot on the planet, and I have looked at this back of the board a few times. And as you may noticed, the CIA chips are missing. I took them out because you don't need them to have a running C64, or at least a testable C64. I hate myself sometimes, so let's put them back in and see what happens then. And maybe, just maybe, the machine simply works. Could be a possibility. So let's check. Not quite sure if these chips are good, actually. So we will find out in a minute, I guess. And that should at least give us some sign of life. Okay, so let's plug it in and let's see what it does. And here goes nothing. I will be damned. I created a working C64 in handheld format. Oh man. So it was the video out all the time. Okay, so now I have to find the fault in the video circuit, because without that I can't connect my screen. So where are we at now? The machine is running in principle, but only if the S-Video connector or cable is connected. I wired up the two boards now. I tested them and still the video signal is there on the composite, but only if this plug is in. So there's still some fault in the video circuitry down here, and I have to figure that out. I don't think that this is the standard C64 design. So what have I learned? I learned that if you build this project, you should definitely build the second board or the main board first. Before you connect the keyboard and the other parts, build this board first, the board with the CPU and all that stuff. Try to get it to work and then go and build the rest, because in theory it should work without the rest, except for the composite signal, which seems to need the connection over here. I don't know why. Maybe it's some ground wire or something like this. And still haven't sound. So I have this little voltage regulator, which should give us, it takes 5 volt input and can give 9 volt output for the SID. So I have to get this somewhere in here. Another thing is, if you get a cartridge port, try to get the angled cartridge port, because I did all this with wiring half of the pins, and that is just a nightmare. They always come loose. I had to solder them, I guess, 3 or 4 times, and it's not fun. It's very fiddly, and especially if there are chips in there, you really have to take care that you don't burn anything. And yeah, do yourself a favor, get the angled one, or find a different method of wiring this up, because my method is obviously pretty shitty. Yeah, so this is the end of part 2. In part 3 I will get this thing to work, and I already have a mounting mechanism printed for the screen. I have a different screen. This is the one that came with a that I ordered from AliExpress, and as far as I can tell, this one has a fault. I have a different screen which is a little bit bigger, and that will make for a very special handheld C64. So I'm very, very curious to see how this works out. And part 3 will be the last part, so I will only post part 3 if I get this thing to work completely. Yeah, see you in part 3. But as you see, it's coming together step by step. And yeah, like and subscribe, and until next time, bye bye. This is Retro is your new black. If you are new to the channel, please like and subscribe. Thanks for watching, and until next time.